Welcome to Study Loop.
In this problem, we are looking at the equilibrium between CCl4 and solid carbon and gaseous Cl2. Let's get started with an ice table. We are told that we have 2 atmospheres of CCl4 to begin with, so we are going to lose some of that, gain solid carbon, and gain 2 equivalents of Cl2 because of its stoichiometric coefficient here. That will give us 2 minus x of CCl4 at equilibrium, x of C, and 2x of Cl2. Now let's think about our Kp expression. Kp is the pressure of products over reactants. So it's the pressure of Cl2 squared over the pressure of CCl4. Carbon is a solid and does not enter into this. So that is going to give us the quantity 2x squared over 2 minus x. That equals 4x squared over 2 minus x, and that equals Kp, which we know to be 0.76. I'm going to multiply over this denominator here. So I'm going to get 4x squared equals 1.52 minus 0.76x. To use the quadratic equation, we have to set this equal to 0. So 4x squared plus 0.76x minus 1.52 equals 0. Now we're going to solve for x with the quadratic formula. X equals negative b plus and minus the square root of b squared minus 4 times a times c all over 2a. This gives you 2 answers. We are going to just stick with the positive root here because our concentrations cannot be negative. So we are going to turn this equation into a plus only. And if you do that math in your calculator, you will find that x equals 0.53 atm. So part A asks you what fraction of CCl4 is converted. Well, we know x fraction is converted, so that's 0.53 divided by 2, which equals a fraction of 0.265. So about 26.5% is converted. For part B, we are going to solve for the final pressures. So the pressure of CCl4 equals 2 minus 2 times, equals 2 minus 0.53 because it's 2 minus x. So that equals 1.47 atmospheres. And finally, the pressure of chlorine equals 2x, so that's 2 times 0.53, which equals 1.06 atmospheres.